So we're going to go through a review for the quiz that's tomorrow. I will tell you there is no proof, full proof on the quiz.
That is amazing.
Okay.
I don't know why.
You don't-
It's like
you don't-
every
they're hard
question
for a lot
is
of
going to
people.
be a miniature proof.
Yeah. No, but there will be questions where you have to identify a reason if given a statement. So it doesn't have to be a proof, but if you see a statement and they say, what's the reason that allows the statement to be made, given this figure or whatever, you've got to be able to identify the statement, okay? But other things that are in these sections are things that we haven't talked about for a while, which are truth tables. You remember those?
Yeah. No.
Hopefully you do. The conjectures, knowing what and or mean, in order for it to be true, both the ands have to be true. But if one of the or are true, then it's true. Remember that? So we're going to review some of that stuff because that's going to be on the quiz as well tomorrow. So I've got the quiz here, and I'm going to go through it and give you questions like the quiz, but not from the quiz. So let's first look at, I'm going to do
Mrs. Reader,
Yeah.
are you by chance going to go over this worksheet?
we can talk about it, but I'm going to go through this first.
Just start chasing.
Okay, so tell me what P or R is and what the truth value is. How would I write out P or R? What's the statement? You're making this much harder than it is.
You just like, don't you just...
If I ask you what P or R is as a statement, what is it?
A right angle measures 90 degrees. Just
Or,
a decagon has 12 sides.
okay, so that's half of it. Okay, now you're going to tell me the truth value of this statement. The statement is a right angle measures 90 degrees or a decagon has 12 sides. What's the truth value of that statement? Remember what the or means. What do you have to have with an or for it to be true?
One of them equal, or one of them's true?
Okay, and is one of them true?
Yes.
So what's the truth value?
True.
True, okay? How would it change if I asked an and?
They both have to be true.
It would be false,
Yeah,
because they would both have to be true.
yeah. So the statement would be a right angle measures 90 and a decagon has 12 sides. Well, a decagon has 10 sides. So the right angle measures 90 is true. Decagon has 12 sides is false. Therefore, if it's an and, it would be false. Why don't we close our Chromebooks? Because nothing's on there that I'm going to be talking about. Okay.
Been here for like 2 weeks.
So what if I asked, let me add one more statement here. And I'm now going to say, I want you to tell me P. Let's do this. Okay, now I'm going to give you that statement. How would you write it as a statement?
Oh, well, okay, if you do a statement.
Doesn't that mean
All of them
P
and-
or S and R?
Mm-hmm.
Okay, so
Can we write it down?
So, what are you asking for?
I'm asking for, tell me what the statement is.
A right angle measures 90 degrees, or a decagon has 12 sides and 4 points are always coplanar.
Okay? So that's a statement. Now tell me the truth value.
A right angle.
true? Isn't it?
False?
Wouldn't it still be true? Is
Here,
there
I'll
any
just make
truth?
this.
Isn't it true?
Okay, so how do we do this?
You have to make it.
You have to do S.
You can do a truth
Yeah.
table.
You have to do SR first.
Okay, so we have to do the parenthesis first.
Oh, I remember the truth table.
So what is S? This is means what?
And
S and R?
Yeah.
So what is S and R? What's the truth value of that?
False.
False, because both of these are false.
So it'd be
So now
true.
I have a true or false. So it's true because it's an or, and only one has to be
Oh,
true.
that's what I thought. Sorry, right?
Yep. It's an or. Let's try another one.
numbers.
Um,
Is there any truth that's true?
No.
No, then you can only.
With an or, if there's more than one true, then it's false. Or
how about this one?
More than one truth.
So if there's two truths on the
P and S or R. So a right angle measures 90 degrees and 4 points are always coplanar, or a decagon has 12 sides.
That's a statement. So what's the truth value?
Wouldn't it still be true?
Okay, so P.
Wait,
I'm so.
if it's and, is
Do
it
the
False.
parenthesis.
Both have to be true.
False.
The parenthesis is false because a right angle does measure 90, but 4 points are not always coplanar. Give me an example of 4 points that aren't coplanar.
When you have a plane intersecting with a line.
Okay, so or maybe 3 points sit on this plane, and then I have another point up here. So these are not on the same plane. Okay, 3 points make a plane, but a fourth point could be on this plane, or it could be up here on a different plane. Doesn't have to be on the same plane. Okay, so 4 points are always coplanar is a false statement. Okay, and if I say P and S, well, P is true, S is false, but it's an and, so both of them have to be true for that to be true. So P and S is false, or R is a decagon has 12 sides, that's not true. So we have a false or false, which makes it false. Okay, when you have the quiz, what I would recommend when you see these 4 statements is right next to the statement, put a truth value next to the statement. You know what I'm saying? Like what I'm going to do on the quiz is list 4, there's going to be 4 actually, 4 things. And what I would do if I were you is I would go to the right of this and say, okay, that one's true, that one's false, that one's false. So then when I'm doing this evaluation, I can just plug in the truth values, and then I know, because it's or and, what the ultimate answer is. That'll help you. Okay? So there's 1, 2, 3 questions like that.
If it's and, both of them
Have to be true.
If
It's or one of them has
So
to be true.
and is like the.
Looks like an A without the line through
Or
it.
is a B.
Everybody good with this piece of it? Okay.
Not is the equal sign with the slash through it, right?
Not is just this.
Sweet.
Not is just not.
that was Peter.
Okay. So let's go on. Let's talk about truth tables. Let's do this, not R. Okay, you're going to be given a truth table that looks like this.
Okay.
P is going to already be filled out for you. No. Got to do these right. True, true, false, 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 false. True, true, false, false. This part will be filled out to you for you through this. So you don't have to fill the rest of it. I mean, you don't have to fill this part out. That'll be filled out for you. This is going to be a multiple choice question, so you've got to find the truth table that's going to match what you find your truth table to look like. So first off, what pattern do I finish Q with?
True, true, false, false.
True, true, false, false. What pattern do I finish R with?
True, false, true, false, true, false, true,
Yep,
false,
it
false.
just alternates.
Yes.
Okay, so I got you started. on the problem, and then you fill in the other pieces of those 3 columns. Everybody good with that so far? It's just the pattern repeating. Okay, so now we're going to do not R. So what's the truth value for the column not R?
The opposite of the alternating?
It'd be opposite.
Opposite of, come on, pen.
False.
False, true, false, true, false, true, false, true, right? If my pen would start working.
Not R and Q.
Is this and or?
Oh, sorry. And.
This is or.
Or, wait.
A
Yeah.
and looks like an A without the line through it.
I'm getting places today.
And this is not working. False, true, false, true. God, I can't get my pen to work. False, true, false, true, false, true, false, true.
Three truths and then a false.
Okay, did everybody try the last column by themselves?
I have
Yes, I don't think
Yeah.
you're right.
Okay, so I'm looking at the last column, and it's an or. And I'm just going to be comparing the not R with the Q. The only time it's going to be false, because it's an or, is when?
If one of them is true.
The only time it's going to be false
They're both
is when they're both false. So not R and Q, I go down right here, right here. There's only 2 falses. It's right here and right here. Everything else will be true. 1, 2, 3, 4, 5, 6, 7, 8.
So I don't understand.
Okay, if it's an or, if either one is true, the truth value is true.
If it's an or.
If it's an or, either value is true, it's true. So another way of saying that is the only time or statements are false is when they're both false.
Okay.
Because if they're both true or one or the other is true, it's always true.
Okay.
So all I did is I found when they were both false. And that's the only time that the or statement's false.
So,
Okay.
Okay, let's do this one now. This way, just to check. Now it's and. So when is it always true with an and? When they're both true. That's the only time. So now I'm going to look when they're both true. It's here, here,
It only happens twice, doesn't it?
and here.
3?
It's the second time and the 6th time when they're both true.
Wait, you just said 3.
I said 2.
Wow. Yeah. guess
My pen's not working, but you see it, right? Okay, the other times it's false. Okay, so you need to know how to fill out a truth table. There will be one problem on that.
It's easy doing it, it's just remembering.
And it will be multiple choice, but it'd be better off for you to fill it out and then compare yours to this, because it would be confusing to try and go back and forth through 4 different answers.
If it's an and then it's 2 falses, but if it's still
False.
false.
Mhm.
Okay.
Yep.
That's the only.
Okay, now we're going to get into the law of detachment, the law of syllogism, the law of contrapositive. Okay, law of detachment. If let's see, if she, let's do is wearing. If she's wearing a coat, then she is cold. That's why she's wearing a coat. If she's okay, so the law of detachment says, first off, what is P here?
she's wearing a coat.
Okay, she's wearing a coat. And Q? Okay, so the law of detachment says, if you're given P then Q, if P then Q, and then they tell you P happens. Okay, so if you're given, if she wears a coat, wearing a coat, then she is cold, and they tell you she is wearing a coat, what's your conclusion?
She is cold.
That's the law of detachment. Not that hard. Therefore, the 3 dots there mean therefore Q. So that's how you write it with symbols. If P, then Q, and then they give you P, therefore Q. That's the law of detachment. Okay? So what if I said, if she's wearing a coat, then she is cold, and I give you Q. Can you use the law of detachment to conclude anything? No. I cannot then conclude P. It doesn't work.
So it's like possible.
So wouldn't it be,
It's possible, but it's not true necessarily.
would it be squiggly line? Non-shift?
That gets into the law of contrapositive,
Isn't that
which I'll talk about in a minute. We're talking about the law of detachment, so be careful, because what I may give you is, if P then Q, and then I may tell you Q happens, don't say that P happens. Understand what the law of detachment is. If P then Q, you have to be given the hypothesis happens, then you can conclude the conclusion happens, not the opposite way.
So what do we do, like what do we put down?
Well, your choices will be it's invalid, or yes, you can use it because of law of detachment, or yes, you could use it because of law of syllogism. Okay? Well, the law of detachment just has one if-then statement. Something that might cue you into the law of syllogism is it's going to have 2 if-then statements. Okay? So, if I do, let's see if my board will let me. If, come on, if, oh God, it's painful. You are, I think I must have a fly flying around that keeps hitting my board or something. Are in 10th grade. They don't have to be true, so I'm just going to make something up here. Okay? I'm just making up crazy things, so. Okay. If you're in 10th grade, then you floss regularly. If you floss regularly, then you like apples.
Syllogism.
So what's the conclusion here?
Type of statement.
You're in 10th, you floss regularly.
You like apples.
What's the
there's
final?
2 of them.
If you're in 10th grade, then you floss regularly. If you floss regularly, then you like apples. Using the law of syllogism.
If you're
What's
in
the
10th
final
grade, you like
statement?
apples.
Yes. If you're in 10th
Oh,
grade,
you take the
then you
top.
like apples.
Okay.
So they cancel out if the hypothesis and the conclusion are the same.
Yes. The hypothesis of the first must equal the conclusion of the second. That's the rule. Then this piece cancels with this, and you're left with, if you are in 10th grade, you like apples. So the law of syllogism must have 2 conditional statements, not just one. And be careful on the quiz, because I won't give them as an if-then. It might just be a statement. You are in 10th grade. You floss regularly. You like apples. So the question is, if you're given the first and the second statement, can you confirm the third? Okay, so what if I said these statements, and then I said, then,
Official trailer Netflix.
I don't know what I want to say. You're in 9th grade.
No,
You're
it's
So if I say, if you're in 10th grade, then you floss regularly. If you floss regularly, then you like apples. And I tell you you are in 10th grade. Can you conclude you like apples?
Yes.
Yes. Could you conclude that you floss regularly?
Yes.
I could, because the first statement says that. Okay? But be careful that it's in this order. Because if I said, if you're in 10th grade, then you floss regularly. If you like apples, then you floss regularly. You can't conclude you like apples from being in 10th grade. The conclusion of the first has to match the hypothesis of the second. It's the law of syllogism. Okay? All right, let me go back because I'm going to show you the law of contrapositive here, if it will move. Okay, so the law of detachment was this. The law of contrapositive says, if P then Q, and I give you not Q, the opposite of the conclusion, then you can conclude the opposite of the hypothesis. The law of contrapositive. If you remember inverse, converse, contrapositive, you switch the conclusion and the hypothesis and you make them both negative. So that's what happened. We switched the conclusion and we made it negative. Then you can conclude the opposite of the hypothesis. So as an example, if she's wearing a coat, then she is cold. If she is not cold, then she is not wearing a coat. That is the law of contrapositive. Okay? If they give you not P, it's meaningless to you. They have to give you the opposite of the conclusion for the law of contrapositive. Questions there? I need to show you with what the law of syllogism looks like with letters. If I could get there. So let's let this be P, this be Q, this is Q, this is R. Everybody see that? Hypothesis of the first is P. Conclusion of the first is Q. Hypothesis of the second is Q. Conclusion of the second is R. So the law of syllogism looks like this. If P then Q, and if Q then R, then if P then R.
So
Law
why
of
P and
syllogism.
Q and
That's
R?
just what they use.
No.
Okay.
Okay.
All right. Law of detachment, law of syllogism, law of contrapositive.
If we ask for help tomorrow on this, would you help us?
No. This is a quiz. Sorry.
You're like on ACT. Hey, what's this? What's this? No, what's the head?
Okay, the next two questions have to do with just knowing your definitions of lines and planes. Okay, so how many points does it take to make a line?
2.
How many points does it take to make a plane? 3. 3 is the minimum number to make a plane.
Oh,
Okay. Then number 9 has you actually pick out which representation is a law of syllogism with letters and symbols. So you'll have to do that. I just wrote it up on the board. And then the last is a property. So you need to know reflexive, symmetric, transitive. It's a property question. Definition of congruence. What does the definition of congruence tell you?
Same.
shape and size.
Yeah, so if I told you that this segment was congruent to this segment, that means that PS is equal to SQ. It's the same measure.
Oh, that's complete.
Okay, and the reason is the definition of congruence. Okay, so you need to know those properties. And that's it. There's no proof. It's all really dealing with the logic we've done so far. Okay. With that being said, we can go through a couple of these proofs if you want to. Which one did you get stuck on?
The third one? Can I go grab mine?
Yes. You turned yours in?
Yeah.
Brooklyn. I don't know what he...
I put mine on your desk, but there was like not
Okay.
even one done.
You put yours on my desk?
That desk right there where you just pick them up.
Oh, okay.
That's Reese's. Okay.
Is Ethan's there?
Yeah.
You take it, okay. Whose is that one?
Catherine.
Oh, she's not here. So which one got you
Okay.
3.
1 through, yes.
1? You guys don't know how to solve an algebra problem?
No, we got
Oh,
one.
no,
No,
okay,
no.
we got 1.
3.
Oh, yeah.
Wait, where's my? I thought someone was gonna-
Okay, angle 1 is equal to angle 2. And mark this with a different color. And 3 equals 4. Prove ABC is congruent or equal to the measure, is the measure of DEF. And you're given all the statements. Okay, so measure of angle 1 is equal to angle 2, and 3 is equal to 4. That's the first line, and that's because it's given. 1 plus 3 equals 2 plus 4. Why is that?
We put substitution.
I put addition.
Yeah, I put substitution.
Well, we don't know they're equal by addition. The segment addition or the angle addition postulate would say angle 1 plus angle 3 equals angle ABC. That's the angle addition postulate. So what did they do to get to the, from 1 to 2?
Pardon the interruption. Teachers, please dismiss the cross-country students at this time. Good luck.
Did she say dudes?
Students.
Oh, say dudes.
1 equals 2, 3 equals 4. 1 plus 3 equals 2 plus 4. Three and 4 are the same thing, right? So they essentially added 4 to both sides, but then they substituted. It's almost like they did 2 steps here. They added 4 to both sides by the addition property of equality, and then they substituted 3 for 4 because substitution property of equality. So really what I think it should have been was that second step should have been measure of angle 1 plus measure of angle 4 equals measure of angle 2 plus measure of angle 4 by the addition property of equality. And now because we know 4 and 3 are equal, we can substitute this with the measure of angle 3 to get that final statement 2. So I think it really was 2 steps. Should be the addition property of equality and substitution.
I nailed that, actually.
Good.
There's a 4th one.
Well, number 3 then,
So we put both of those.
Both of those on 2?
Yes.
number 3 is the addition, the angle addition property. Because they're saying angle 1 plus angle 3 is equal to ABC. Angle 2 plus angle 4 is equal to DEF. That's just the angle addition property. 2 angles added up equal the whole angle. This plus this is equal to ABC. This plus this is equal to DEF. The reason is the angle addition property. That's number 3. And then 4, I think, is substitution because 1 plus 3 is ABC. So they just substituted ABC for 1 and 3. 2 plus 4 is DEF, so they just substituted DEF there. So that last one is substitution. Yeah, no, and this proof doesn't even start right because you should start with a given. Oh, they did. They put that at number 2. Okay, so at least they have it in there. So number 2 is given. Number 1, angle 1 equals angle 2, vertical angles, definition of vertical angles.
Which one are you on?
Number 4, second page at the top.
So,
So number 1 equals angle 2, that's definition of vertical angles. 2 equals 3, that's given. 3 equals 4, definition of vertical angles. So if 1 equals 2, 2 equals 3, 3 equals 4, 1 equals 4 by the transitive property of equality.
Wait, so
Wait, what was for?
Transitive property. If
So-
1 equals 2, and 2 equals 3, and 3 equals 4, by the transitive property, 1 has to equal 4, which is the last statement.
and 3 is definition of vertical angles.
Uh-huh.
Oh,
I'm not going to do all of them, but we'll skip down. What was another one that caused you problems?
we haven't even. We didn't
Yeah,
get
we
this
didn't
far.
do.
Okay. Well, maybe work on number 6 right now, and we'll come back together in about 5 minutes, and so we get out at 46. Is that right?
Well, what about 5?
Yeah, we'll do.
Okay, do number 5 then. Whichever one. Pick one.
Wow, there's.
What?
Perpendicular.
Yeah, that's the one.
I was thinking congruent, and I don't know why.
Thank you.
We're getting close.
No.
I got stuck on 5.
Okay, so if 1 and 2 are complementary, that's given.
Mm-hmm.
Angle 1 plus angle 2 has to equal 90. That's the definition of complementary angles.
Number 3 would be substitution POE.
Nope, that's the angle addition property. Angle 1 plus angle 2 equals the whole angle AXF.
Oh.
AXC, I mean. That's the angle addition property.
what was number 2?
Definition of complementary angles. Then you can say angle AXC is also 90. You could use either substitution or transitive for that one. Property of equality.
For 4?
Uh-huh.
Okay.
What was 3?
Well, just
3 was angle addition property. Then AXC is a right angle, definition of right angle. Sometimes I think you guys overthink these.
I definitely would.
And now you can say, remember the last statement of any proof is always what you're trying to prove. So it's just XA is perpendicular to XC. And the reason is definition of perpendicular.
How did I make this so hard?
They're not that hard. You're just using definitions and
What was the last one?
definition of perpendicular.
Mine feels stupid, like always.
So we've still got time. Take your shot at number 6.
Sweet.
Now you're doing all the statements, except the
I'm
very
trying to
last
shoot
one.
my shot with the types of things that look like I can actually achieve.
Look.
I'm gonna see.
The number 1 and number 6 should be a given to you, right?
Yeah.
So that's easy. What's the definition of supplementary angles tell you?
They equal 180
Okay.
degrees.
So number 2 should be a given to you.
What's the?
The vertical angles are congruent. That's going to tell you that, what, angle 1 and angle 3, as well as angle 2 and angle 4, are congruent? The vertical angles theorem? 1 and 3, 2 and 4.
So how do you write that?
Angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Congruent is the equal sign with the squiggly on top. The definition of congruent angles just tells you the measure of each one of those angles is equal. So if you know that angle 1 is congruent to angle 3, you know the measure of angle 1 is equal to the measure of angle 3. And the measure of angle 2 is equal to the measure of angle 4. You just put an m in front. M angle 1 equals m angle 3. M angle 2 equals m angle 4.
For the last one, we would.
You're just substituting 3 and 4 in for 1 and 2, right?
Yeah.
So it should be the measure of angle 3 plus the measure of angle 4 equals 180. You just substitute in 3 and 4 for 1 and 2. And so what's the final blank for the reasons in number 6?
Angle 3 and angle 4 are supplementary. Definition of supplementary.
There you go. Supplementary angles, but yeah. Okay, so see if you can finish this up. We have a quiz again tomorrow. I've gone through that. I have recorded all of this, so if you want to watch it again.
Yeah, I'm gonna need to watch
What's number 6 on number 6?
Supplementary angles.
I mean, that's what we read.
The proof, the statement is exactly what you're supposed to prove. The statement is always the proof.
Oh yeah.
Today's 3.